This is an introduction to the CER statement. C stands for claim, E stands for evidence, and R stands for reasoning. CER statements are a way of presenting your argument, but they are based on evidence and not just on your opinion. So it's a very logical format for presenting an argument, but it uses evidence, not just opinion. CER statements are an important tool that you will be using not only in POTU, but in all of your science classes. You will be graded on how effectively you use this tool. So claim, evidence, reasoning statements are going to become a very important part of your arguments in science. So let's go through a quick example of a CER, how to use it, and then we'll have you write this out on another example. First, let's start with the claim. The claim is where you actually answer the question, and it's a complete sentence or maybe two sentences. So it's always going to be a complete sentence, and it's where you actually answer the question. Now, the thing about this is, even though this is the first step, claim, in claim, evidence, reasoning, most of the time, this is the part you write last, because you have to look at your evidence and analyze what's going on first before you come up with your answer in most cases, unless it's a pretty easy answer and you already know it. So even though claim is first, you tend to write this later on in the process. So here's our example. Make and support a claim as to whether Usain Bolt can outrun a deer in the 100-meter dash. So what do you think? What will be your claim? Who would win a 100-meter dash? Usain Bolt or a deer? Now, the first step says make a claim. But at this point, you really don't have enough information. It would just be basically your opinion. You would be thinking, oh, I think Usain Bolt runs fast, or I think that deer runs fast. So this is where the evidence comes in. So you can't really answer your question yet until you look at the evidence. So let's look at the evidence. Evidence. This is where you identify what data is used to support your claim. Now, the thing about evidence is often you're presented with extra information. So what you have to do is look at all the information given to you and pull out the important part or parts that help support your claim. Let's look at some evidence. We have some evidence here that I looked up online, and you can see the top speeds of Usain Bolt and a deer: 23.35 miles per hour or 10.44 meters per second for Usain Bolt, 31.5 miles per hour or 14 meters per second for a deer. And we also have the maximum range for a deer and Usain Bolt when they're running. So this is going to be your data. Now you can't just say my evidence, what's my evidence, and then just copy and paste all this. This is just too much information. You got to pull out the important parts. Well, I'm looking at this, I'm thinking, what's important for figuring out who's going to win this 100-meter dash? It's their top speeds. These numbers right here tell us the evidence we need to figure out who's going to win this race. Let's go back to this step, evidence. Here's my evidence. I wrote it like this. Usain Bolt's top speed is 23.35 miles per hour, while the deer has a top speed of 31.5 miles per hour. That is my evidence. It doesn't explain how this evidence supports my reasoning, but this is the important part of the evidence that I have to use. Now let's talk about the reasoning. The reasoning is where, this is what makes a difference between a 2, a 3, and a 4. And this is where you're doing, often doing most of your writing or half the writing. It's in two parts. First, it describes the evidence, how the evidence supports the claim. And then you also usually have to show some kind of scientific principle that supports it. So first, our evidence. There are different ways of writing this, but here's an example of what I wrote. During a short 100-meter race, the deer has the faster speed of 31.5 miles per hour compared to Usain Bolt's speed of 23.4 miles per hour. So it should win the race. So here's where I'm using my evidence, the speeds, and I'm explaining that the faster the speed of the deer means it should win the race. Now, the other part is scientific principles. So this actually doesn't explain exactly why the deer wins the race, but if we combine it with the scientific principle, in this case, it will help explain it exactly. So here's scientific principles. How do you measure the time that it takes for something to run a race? And so using arrow math, I can use this as my evidence. The distance is going to be the same no matter who runs it. It's going to be 100 meters, so distance will be constant. And then I can see that the deer has a faster speed than Usain Bolt. So speed is going to go up for the deer. Higher speed, and this is on the bottom, and since I'm dividing by a higher speed, that's going to make this side smaller, so that makes time go down. Okay, so and actually this is what I solved for, time. So what you can see is faster speed means less time. Faster speed means less time, and so that explains why the deer will win. Using the speed equation, we can see that as speed increases, time decreases. The faster deer takes less time for the race. Okay, so there's my two parts of my reasoning. The first part, use the data and explain how the data links to the evidence right here. And the second part uses scientific principles to back up why the deer will win. So there is some leeway here for your reasoning. For example, instead of using arrow math, you could have actually used actual math to calculate how much time it would have taken for each of them. So here's our equation. Speed equals distance over time. Okay, in this case, what we have is Usain Bolt is 10.44 meters per second, and the distance is 100 meters, and solve for time. Okay, so I multiply time on both sides, and this reduces, and then I have to divide by 10.44 on both sides, and that reduces. So time equals, put that in my calculator, and I get 9.6 seconds for 100 meters. Now over here, for the deer, let's do the same thing. And so we see the deer only takes 7.14 seconds for the race, and Usain Bolt will take 9.6 seconds for the race. So the deer definitely wins. We could have used this for our reasoning instead of arrow math. So now that you have all of your reasoning and evidence done, don't forget to go back to the claim. All right, I always have students who get through those last two parts, that do all the work, and then they forget to go back and write their 1 or 2 sentences for the claim. So the claim is the answer, so it's really important. Without the claim, you can't get anything higher than a 1. So here we go. Here's what I wrote for my claim. A deer would win a 100-meter dash race against Usain Bolt. That's my claim. There you go. Now you're done with that assignment. Okay, so now go ahead and pause the video and get these 2 papers from Mr. Colby. You're going to need the example claim evidence reasoning scenario, and you're going to need this half sheet, the CER statement. What you're going to be doing is you're going to be taking this paper, this half sheet, and you're going to write out your answers in here. Okay, write out your answers in here, and when you're done, you're going to glue this onto page one of your notebook. So here we go. Okay, so you have on your yellow paper, this is an example of a CER assignment. Here you perform an experiment with 4 different blocks of material to see if they each float in a cup of water. The results are recorded in this data table, and then there's some information about what is mass, volume, and density. And here's your evidence right here. Lots of numbers and lists. The claim: what determines whether or not the block will sink in water? That's the answer. That's the question we have to answer. What is it about the blocks that make it sink in water? And it says here, the hint, your answer is basically going to be the same as one of the headings at the top of the data table. So it's telling us that basically our answer is either going to be mass, volume, or density. Which of these three things tells us whether or not the object will sink or float? That's what our task is to do. So before I can write the claim or write the answer, I have to look at the evidence, and that's where I'm going to spend most of my time, looking at the evidence and then writing about it. So let's focus on this data table right here. So look through this data table, and what are you noticing? All right. So one thing I do want to point out, I'm looking at sinking and floating, and I notice that these three sink and this one object floats. So what we want to do is look for patterns over here in this part. What over here matches sinking and floating? Okay, so first what you should do is go through the masses right here and see if there's a pattern between mass and sinking and floating. So look at these numbers and compare them to sinking and floating. Usually we look for things that are like maybe higher numbers and lower numbers. Do any higher numbers or lower numbers, is there a pattern here that lines up to sinking and floating? What do you think? All right, what I notice is all three of these right here are sinking, and we have some high numbers and a very low number that sinks. But over here we have a low number, but it's not as low as this. So mass does not look like there's any real pattern. Masses are sort of all over the place. Sometimes the light mass sinks, and sometimes the heavy mass sinks. So I don't think mass is going to be our answer. Let's look at volume now. So look at these numbers and see if they line up and make a pattern with sinking and floating. What do you think? Is there a pattern? What I notice is the highest number, 4.5, sinks, but the second highest number floats, and these low numbers sink. So again, just like mass, there doesn't seem to be a pattern, because sometimes low numbers sink and sometimes high numbers sink. So volume is probably not our answer. All right, let's look at density then. We're down to our last column. So now look at these numbers and compare them to sinking and floating. Do you see a pattern? What I notice is this lowest number is this object, that's a clear object, is the lowest number, and it floats. These other three numbers are all higher than 0.85, and they're sinking. So this is probably an indication that density is what determines if it sinks or floats. So putting it together, since these are not the answer and this seems to have a pattern, I'm going to use this for my answer. Density is what is going to be my answer. Now I got to write this out. These numbers, density, and write it out for my claim evidence reasoning. All right, claim. Well, actually, I think I'm ready to write the claim because I did all the thinking already. I went through all the evidence and figured it out. So even though I didn't write out the evidence or the reasoning, I have some reasoning in my head. So I'm going to write my claim right now. What was it that we said is, which of these three things is the thing that determines whether or not it will sink or float? It was density. So that's going to be my answer. So I'm going to write this right underneath here. High density objects will be more likely to sink than low density objects. And that's it. That's basically my claim. So go ahead and write this down on your paper underneath of claim. That's our example. Write this down. You might want to pause it when you do that. Okay, now our evidence. We have to use some of the data from the table. And there's a lot of evidence here, but none of this helped us out with our answers, so I'm going to sort of ignore that in my evidence part. Really, it was the density numbers. So here are the numbers I noticed. These objects sank and this object floated. So that's going to be my evidence. I'm going to write that down in a couple sentences. All right, so here's what I did. All of the objects that sank have a high density. Metallic is 2.7, white is 1.1, and copper is 8.96. Those are my numbers. That's my evidence. Clear floated, and its density is low, 0.85. So notice I not only did I write the numbers, but I qualified them right here. I said low and high. So this is setting up, showing that I'm thinking about the evidence and putting it in terms that help support my argument. So go ahead and write this underneath evidence on your half paper. Copy this down on your half paper. And now finally we're going to write the reasoning. This is the part that's kind of the trickiest because you have to link this all together. And so big picture, what I'm noticing is this. The three with the highest density sank, and the one with the lowest density floated. Not only that though, I did look at my mass and volume, and I saw that these were random and didn't have anything to do with the sinking and floating. So I want to point that out. So here's my reasoning. The three objects with the highest density were the ones that sank, while the lowest density object, the clear one, floated. So also, the masses and volumes seem to have a random effect. Therefore, the density determines if an object floats. So you gotta make a statement like this that links it all together. So go ahead and copy this underneath your reasoning. I know it's long, but that's the main part of your argument is the reasoning. So it tends to be the longest part of the answer. And finally, scientific principle. You want to explain why this happens. In our class, we're usually going to be studying specific principles, so you're going to kind of know which scientific principle to use and explain. In this case, I think it has something to do with density versus density of water. So let's Google up the density of water. When I did that, what is density of water? It comes up with 1 gram per centimeter cubed. This is the density of water. So that's interesting. So the thing that floats is less dense than water, and the things that sink, even white is 1.1, is more dense than water. So that kind of explains why these things float. So I'm going to write something about that to cover the principle. Water has a density of 1.0. Objects with lower density than water will float in water. So that's sort of my scientific principle. So you want to see if you can add that to your paper. Once you do that, we're done, and you can go ahead and glue this in to your notebook once it's filled out to page 1. Remember, page 1 is right after the yellow paper, right after the table of contents, page 1. We want this right here on page 1. That's how important it is. Claim, evidence, reasoning statements. You will be using this on almost all of your formative assessments. You will use this a lot. So glue this down, and then we'll finish up.